So it's the first time you see a matrix, so let's see some basic information about it first. Matrix, we use small brackets and we put some numbers over there to make like a size of rectangle. For example, we can have 2, 3, 1, 1 minus 1, 2. And so we call a matrix. And a matrix carries a size. And you see it consists of two rows, and then 3 columns. So we call this one is called a 2 by 3 matrix. So 2 and 3 representing the size of the matrix, or you may say it represents like a rectangle. So matrix can be called just a row like 103. That is called 1 by 3 matrix. It can be columns size 1, 2. So that is called 2 by 1 matrix. And of course, we can have a square size like 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's called 3 by 3 matrix. Coming up next, of course, we learn a new thing called matrix. We need to know the basic operation on it. So that means we're talking about plus, minus, multiplication, and division. Let's start from plus or minus first. So when we are talking about plus or minus, so you have to note that they should be of the same size. So what does that mean? Would be like so you have we have notation as follow. Okay, A matrix is called 2, 1, 2, 1, 2, 1. B matrix is called 102, 204. For example, when we are talking about A plus B, so you have to make sure that they are of the same size. You see it is 2 row, 3 column, 2 by 3 matrix, 2 row, 3 columns. So that's why they can be added up together. So the addition will be very simple by adding up the elements. So 1 by 1 according to the position. So 2, 1 is 3, 1, 0 is 1, 2, 2 is 4, 1, 2 is 3, 2, 0 is 2, and the last 1, 4 is 5. So then let's talk about addition. So next we may be also talking about multiplications, so called 3a, say plus 2b. So it is called scalar multiplications because we are multiplying a 3 over there. And then when we are talking about multiplying 3 in matrix, it means you need to multiply 3 in all the numbers. So that's why it comes to 6, 3, 6, 3, 6, 3. So similarly, when we're talking about 2b, so you need to multiply 2b in multiply 2 in every element in b, which gives you 204 and 408. So finally, you get the answer by, again, addition of the numbers accordingly. So you have 8, 3, 10, 7, 6, 11. Next, we come to another part about multiplications. And then, so let's have another new page. It was a very, very complicated thing because so there is some restriction there. Like we talk about A is 1, 2, 1, 0, 2, 1, let's say. And then B is not in the same size this time. So like 1, 2, 3, 0, 2, 1 for A and B. So what do you mean by multiplication? So we also skip the multiplication sign by writing down A, B only. And then next, in multiplication is harder. Okay, wait. Because you need to remember a rule very carefully. The rule is horizontal multiply to vertical. So what I mean is 1 to 1 is multiplied to 1 to 3 accordingly for the first number. So 1 and 1 is 1. 2 and 2 is 4, or how about I write like this, 1 plus 4, 1 times 3 is 3. So this is the first number in the matrix. All right, next number will be 1 to 1 multiply 0 to 1. 1 and 0 is 0, 2 and 2 is 4, 1 and 1 is 1. Wow, very terrible. Green color, 0 to 1, 1 to 3. You have 0, plus 4, and plus 3. Last color, 0 to 1, 0 to 1, you have 0, 4, and 1. And it is called the multiplication of a matrix. Finally, you simplify the numbers and you've got 8, 5, 7, and 5. This is called multiplication. Right, next we can have some other examples like how about 103 multiplied to 201. Then it's a very strange answer because 103 multiplied to 1201. So you have 2 plus 0 plus 3 is a 5. That's all. So that's why the matrix becomes a single number. We may have a situation like let's say 1031 multiplied to -2 and 5. Then in this case, we first 10 multiplied to -2, 5. So you've got the first number called -2. Next, we have 31 multiplied -2, 5. Then you have -6 plus 5 gives you a -1. Then it comes to another matrix. Generally speaking, you will find that multiplication requires you a very clear mind in doing multiplication, and you have to note the size as well. And then so if you want to have a more precise look about how we can do a multiplication, then you have to note that, for example, like let's wait. A is a m by n matrix. So that means m row, n columns. Then if you want to do the multiplication properly, then B should be n. That means column and row, they should be fit. And then so it goes to m by p matrix. Then in this case, multiplication should be valid. And so at last, when you combine them and give you AB, the size will becomes M and P, M by P matrix. So now you can take a look on the two examples on top. And then so this is called 1 by 3 matrix. And this is a 3 by 1 matrix. So that's why the outcome is only 1 by 1. That means it carries a single number. This one is a 2 by 2 matrix, 2 by 1 matrix next. So the outcome becomes a 2 by 1 matrix. After we take a look on what's the meaning of invalid multiplication in matrix, let's say, so I give you an example like this. So like 2112 multiplied to 301. So it seems we can do it, but if you read it precisely, you see 21 is not matching to 301. Neither of 12 multiplied to 301, both are not, invalid. So that's why so you can see it's an unvalid multiplication here. At last, we want to talk about division of matrix. So but unluckily, so it's undefined. So what does that mean? What do I mean is, if you want to have A division of B, so then it's something undefined. We can't find anything about it. The only case we can do division will be only on scalar division. So for example, like A is 4, 8, 12, and 16. And then so I want to do about 1 over 4 of A, or you may say talking about A over 4. So in this case, because we are only doing a division of scalar, dividing by 4 on the matrix A. So in this case, it can be treated as multiplication, whereas every number divided by 4, which gives you the results of 1, 2, 3, 4 afterward. Similarly, we can have B, another matrix called like 6, 12, 18, and 3, let's say. So 1 over 6B gives you have 1, 2, 3, and 1 over 2 in the outcome.